Welcome, science students. Welcome to today's lesson, What is a Wave? All of you really have probably experienced waves in lots of different ways. Think of a time where you've experienced a wave. Some of you, I'm sure, have been to the beach. Or maybe you've been on a boat. Perhaps you've been to Waterworld or a sporting event. Or maybe you like to dance. I think just about everybody has experienced waves. But all of these different instances are not exactly the same here. All of these different examples, though, have some of the same properties and they can be defined and described. We would consider all of them a wave. They all end up transferring energy from one place to another. And that's actually going to be a key idea in our definition for a wave. A wave is a disturbance and it transfers energy, but it does not transfer the matter. We'll come back to that idea of not transferring matter here in just a little bit. But first, let's focus on that transfer of energy. Think about falling water. You've seen raindrops falling on a surface of water. The water drop is falling. It's being pulled by gravity. That force of gravity ends up causing that water droplet to go smashing into the surface of the water. The energy from that descent, as it's being pulled down, it's accelerating, moving faster and faster and faster. The energy of that acceleration is transferred across the surface of the water by a wave. Let's revisit that idea of that wave pool. It might help us understand that idea of the matter doesn't transfer much. Here we can see someone sitting on their tube. They're in that same location, left to right, as when they start. The wave approaches from the left and elevates them in their tube. But notice the tube is still in that same central location it was. The tube has not been pushed forward. It's been raised and tilted up. As it's climbing up that wave, it eventually reaches the top. And you can see it's still lined up in that same central location. It hasn't been moved. It hasn't been pushed. It's been elevated. Its energy has increased because its potential energy, its position has increased. Here at the top, it then starts to fall back down the backside, but again, kind of more of a tilt as opposed to vertically being moved to the left. Horizontally moved to the left. And that wave continues to move across the pool, and eventually it passes, and that person's exactly right back where they were. They didn't get pushed around in that pool. I think it's also important to realize that all of those items there are still water, and the inflatable tube is still that same inflatable tube material. That person is still that person. That transferring matter, you could also think about some instances where energy is transferred, but the matter changes a bit too. I think of explosions off the top of my mind. That transfers energy, but that explosion itself, that transfer of energy rearranges the matter. And so you get those atoms in different places that would transfer or go from one spot to another. So waves don't change the matter, but they do transfer energy through it. That matter did not get moved. That matter did not get relocated. But the energy does flow through them in the direction of that wave. Water whether that's the ocean, the lake, the wave pool, they're all examples of mechanical waves. And that's because they travel through matter. Remember, matter is anything that has mass and takes up space. This could be things including solids, liquids, gases, things like the air, water, things like the ground. All of these can transfer energy through mechanical waves. And that's actually going to be another key vocabulary term you need to make sure and add to your notebook. A mechanical wave is a wave that can travel only through matter. So it has to have matter to travel through. That idea of having to have matter means that mechanical waves can't travel through a vacuum. They must have some sort of a medium. And that word medium is used to refer to the material. That's going to be another key vocabulary term. Mediums are a material that waves travel through. We'll learn a little later that there are some types of waves other than mechanical waves that can travel without a medium. We'll learn more about those later. For mechanical waves, there are two types: transverse waves and longitudinal waves. We're going to focus on transverse waves today, and you'll see longitudinal waves another day. Transverse waves have a direction of motion, so they're moving in a direction. In this example here, they're moving from left to right. The energy is going in this direction. And the particles, though, get raised up and down. So they're perpendicular to the direction of the motion. And that's part of the definition for a transverse wave. They move perpendicular to the direction the wave travels. You want to add a transverse wave into your definitions. A wave where the disturbance is perpendicular to the direction of the wave travel. As they travel, moving up and down, we call those highest points that they reach a crest of the wave, the very top of the wave. As you fall off of the crest, you end up down at the bottom, which is what we call the troughs. Troughs are those lowest points. Both of those ideas should be added into your vocabulary section. The crest is the highest points on a transverse wave, and the trough is the lowest point on a transverse wave. That's the end of today's lesson. Feel free to watch this video as many times as you need. I hope you have a wonderful day,